Hello guys, welcome to the part 1 of previous year's questions regarding GATE exam of the topic basics from the subject electric circuits. So this is what I have solved so far. I have solved previous year's questions from the year 2019 to 2010 in reverse order, and there are a total of 22 questions. Okay, you can see. And out of these 22 questions, I'm having an issue with this question over here, which was asked in the year 2010, and I have zero clue regarding this question. So I will be posting a video later on regarding this particular question's solution and the appropriate answer. So for the time being, I shall be discussing each and every question that has been asked in the previous years regarding GATE exam. So let's get started. Let's move on to the first question we have, that is from the year 2019. Only one question was asked and it carried 1 mark. Okay, this is your required circuit diagram, and they are asking you to find out the value of this particular current over here. Okay, you are given this entire circuit, and you have to round off the value of current to 1 decimal place. Okay, this is the question. Now what we are doing is get yourself a reference node, because we are going to apply nodal analysis. And if you have any issue regarding nodal analysis, do watch my video regarding nodal analysis, and I will be linking that video in the description box. Make sure you check the description box as well. So let's get back to the question. Here we are having this particular circuit. So get yourself a reference node and mark this ground terminal. Now what we are doing is we are applying the basic nodal analysis. Okay, this is current given to you, this is your current, and here you don't have current, so we will be using that V by R method. Okay, that is Vx, and since you go here you find a positive terminal, so we will be writing minus sign. Okay, so it will be Vx minus 5I upon 3R. Okay, so this will be your required nodal equation. On solving it, you get the reference node voltage as 17.2 volts, and by nodal analysis you know that the value of this current is actually Vx minus 20 upon 2. Okay, so when you put the value of Vx in this particular equation over here, you get the value of I as 1.4 ampere. So this question is pretty easy and nothing to be worried about. Now we have next question, which was asked in the year 2018. Okay, the question carries 2 marks, and this was the only question that was asked in the year 2018. And what we have to find is the equivalent impedance of this particular circuit over here. This circuit is actually an infinite ladder. This part of the circuit continues till infinity, and what you have to do is you have to find the value of equivalent impedance of this entire circuit. Now what we are doing here is, first this would be your Z1. Okay, let's suppose this is your Z1, 9 ohm. Okay, then we assume this branch as your Z2. Okay, since these two happen to be in series, so we will add them. Okay, it will be 5 plus minus 1, so it will give you J4 ohm. Now this particular branch over here keeps repeating, and hence we replace this entire ladder from one component as Zeq. Okay, you replace this entire repeating stuff by Z equivalent. So what you get is a series combination of this Z1, okay, with a parallel combination of these two. This is your Z2 and this is your Zeq. Okay, so what we are going to write is Z equivalent equals to this Z1, this is in series, plus this is a parallel combination of Z2 and Z equivalent. This is your Z2 and this would be your Z equivalent. On solving this particular equation, you get a quadratic equation in terms of Zeq, which on further solving gives you the value of Zeq as J12 ohm. Okay, so this would be your answer. Now we are moving on to the next question from the year 2017. Here 2 questions are asked, and the first question is, it is carrying 1 mark. We have to find out the power supplied by the 25 volt supply. Okay, the power delivered. What we are doing over here is we are taking node, and at this particular node we are applying the funda that the sum of all incoming currents equals to the sum of all outgoing currents. So you see this particular current is actually incoming, this is also incoming, but this one is outgoing. Okay, so sum of incoming equals to sum of outgoing, which gives you the value of current as 10 ampere, and you know the value, the formula that power equals to V into I, which gives you power as 250 watts. So this is all for part 1.